All right, and hello and welcome to your trigonometry class for today. And today I'm just going to review some of the examples that we discussed in class, where we were basically converting from degrees, minutes, and seconds, or DMS, and where we were converting from degrees, minutes, and seconds, or DMS, to degrees and decimals, or DD, and vice versa when we were converting from degrees and decimals. Wow, that is all ugly looking D. Or vice versa when we were converting from degrees, from decimal degrees to DMS. Okay, so what are the examples, that I'm going to be discussing with you guys today are basically examples 6, 7, and 8, and they begin on page 40. And on page, example number 6 says converting from degrees, measures, or degrees, minutes, and seconds to degrees decimal. So we're going from DMS to DD. And in example number 5, we have 17 degrees. Let me erase this so that we have more space. So we had 17 degrees. Um, 39 minutes and 22 seconds. Okay. 39 minutes. 39 minutes. And we know that minutes has one apostrophe or tick mark. And, well, actually, I call it apostrophe. I don't know if that's the correct term for it in math, but we'll call them apostrophes. In 22 seconds. Okay. So if I want to convert this into degrees and decimals, I want to convert the minutes and the seconds. So I'll start with the 39. So pretty much 17 degrees doesn't change. It stays the same. 17 degrees stays expressed. And I'm going to change the minutes. So 39. Now remember that 1 hour has 60 minutes. And in your book, they don't really do this. But I'm going to do this extra step just for the benefit of those people who might be a little bit more visual that need to know exactly what happened. And basically, I convert minutes, and I use that. And I'm going to read from your book. It says, write the number of minutes in decimal form where 1 minute equals 1 over 60 degrees. Okay. The problem wants us to round our answer to the nearest thousandth. So I'm actually just going to go ahead and give you your answer already rounded up. So what I do here is I multiply 39 times 1, which is obviously 39. And then you have 39 divided by 60. 39 or 39 60th of a degree. You guys can say that. And basically, and this would equal to 39 0.65. So I know that I have part of my answer already in decimal degrees, and then the next thing I'm going to do is with the 22 seconds. Now remember, 1 hour has 3,600 seconds. So I'm going to read from your textbook the explanation that they give. And basically, in the textbook, they're saying write the number of seconds in decimal form where 1 second is 1/3,600th of a degree. So basically, we're going to say 22 seconds multiplied by 1/3,600th of a degree. So 1 over 3,600th of a degree, 3,600th of a degree, 1/3,600th of a degree, and we're going to say 22 times 1 over 3,600 of a degree. That would be 22 over 3,600 of a degree. And when you divide that, you get, I believe it's 0.0061. Okay. And this answer could probably, I'm giving you, is probably rounded off already to the nearest tenth. If you do it in your calculator, you'll probably find out that the answer in the book is probably rounded off. So 0.00 0.0061. 0.0061. And what I'm going to do now is just add. I'm going to say 17 degrees plus 0.65 plus 0.0061. And when you add that, that's going to give you your answer in decimal degrees. So if you add 0.65 plus 0.061, the answer that you're going to get is 17.656. So this will be 17.656 or 656 degrees. And this is in decimal degrees form. Again, you just added 0.65 plus 0.0061, and you get 17.656. So that's pretty simple. Now we're going to see one where we're doing the opposites. We're going from decimal degrees to decimals, minutes, and seconds. And that would be example number 6, if I'm not mistaken. Example number 7. It says, convert 29.538 degrees to degrees, minutes, and seconds. Round to the nearest second. Okay. So what we're going to do is we have 29.538 degrees. 29.538 degrees 538 degrees. And the first thing I'm going to do is separate. And I'm going to say 29 plus 0.538 degrees. So the easiest thing now here is to convert it to minutes. So when we're going from decimal degrees to decimal minutes and seconds, the conversion factors are different. So plus 0.538. So what I'm going to do now is convert the 0.538 into minutes. Now I'm going to read from your book for a minute. And it says, to find the number of minutes, multiply the decimal part by 60, since 1 degrees equals 60 minutes. So we're just basically going to leave the 29 expressed. We're not really going to do anything to the 29. The degrees is going to stay there. And we're going to say plus, and we're going to multiply the 0.538 by 60, because 60 minutes equals 1 degree. And we're going to multiply it by 60 and divide it by 1. Again, I'm probably going to give you the answer. I don't know if I think it's exact. So if you multiply, again, it says to find the number of minutes, multiply the decimal part by 60, since 1 degree equals 60 minutes. So we multiply the 0.538 by 60, and we get our answer is 32.28. So 32.28 and now our degrees stays the same. We know that this is our minutes, but I'm actually going to take that 29 degrees and I'm going to take the 32, leave it expressed, but those decimals, since I'm going to minutes and seconds, I'm actually going to say plus 32 minutes, and I need to find the seconds. So minutes plus 0.28. So I have to multiply that 0.28. Now, why am I going to multiply by 60? It says write it, simplify, write as a sum. To find the number of seconds, multiply the decimal by 60, since 1 second equals 60 degrees. So this is, I separate the 32 and the 0 and the 0.28, and this is 0.28. And 1 second equals 60 degrees. So you're going to multiply this by 60. And this is going to be 1. And if you multiply 0.28 by 60, that's going to give you your seconds, the seconds that you need to have this written as DMS. So when you multiply 0.28 by 60, your answer is 16.8. So you're going to say 29 degrees, 32 minutes, and 16.8 seconds. However, the problem is telling me to round my answer to the nearest second. So 16.8 is closer to 17, which means this is going to be 29 degrees plus 32 minutes, or actually not plus, I'm sorry. We don't need the plus sign here. There you go. So 29 degrees, 32 minutes, and 17 seconds. And 17 seconds, ladies and gentlemen. So that's example number 7. And we have one more example for this video lesson. And then that would be the end. All right. So now we're going to find the trigonometric values of the functions of degrees decimals. And if we look at example number 8, which is on page 42, I believe, it says evaluate the following trigonometric functions for the specified angle measurements. Round your answer to 4 decimal places, and we have 18. We're being asked to find the sine of 18 degrees in 9 minutes. Now, in order to find the sine using a calculator, we need to have them in decimal degrees, or either where there's no decimal, like say the sine of 20, or in decimal degrees, which is like, let's say it's 29.2, right? Or something like that. So we have our answer, or they're asking us to find the sine of 18 degrees in 9 minutes. So what I need to do is go from decimal degrees to decimal minutes and seconds. So what we're going to do is, again, separate this, which is, you're going to say 18 degrees, and plus, well, the 9 minutes. Now we're going to say 9 times 1 over 60. And again, if we're going from DMS to DD, or decimal degrees, the conversion factor that we're going to use is this one, because it's saying you have to remember that one here we go. Sorry for a second. Remember that 1 minute in decimal form, it says 1 minute equals 1/60th of a degree. So 9 minutes is 1/60th of a degree, which is going to be 9 over 60. And then I'm going to divide 9 over 60. And that's going to give me my answer, or convert those minutes into decimal degrees. And 9 over 60 is 0.15, which means I have 18 degrees. Now, why am I not using or converting this to seconds? Well, because my answer was just given to me in degrees and in minutes. They didn't have a second. So I'm just going to add 18 degrees to 0.15 to 0.15, and that would be 18.15 degrees. And now I can use a calculator and find the sine of 18.15. So you only do this step when the answer is given to me in degrees, meters, and seconds, in which case I would have to convert to decimal degrees. Okay, so again, all I did was I converted 18 degrees in 9 minutes into decimal degrees, which is 18.15. And then you look for the sine of that using a calculator. And the number that you get, and I'm just going to give you the approximated number, but basically you have to round it to 4 decimal places. So the sine of 18.15 degrees equals, or is approximately, 0.3115. 0.3115. 0.3115. And that's how you would find the sine of 18 degrees in 9 minutes. Now let's look at the last one that we're going to see for this video, which is the secant of that looks like a 5, but it's an S. It's the secant of 29.524 degrees. 29.524 degrees. And again, we have the advantage here that 24 degrees. Sorry, guys. We have the advantage here that this is already given to me in decimal degrees. So I really need to use the identity. And I know that to find the secant, I say 1 over the cosine. So the secant of a function, or the secant of z, is 1 over the cosine. In this case, I'm going to say the cosine of 29 29.524 degrees. .24 degrees. 1 over the cosine of 29.524 degrees. So what you're going to do is find the cosine of 5.24 using a calculator, which they already did in the book, in your book. They say that the cosine of, basically what you do is you look for the cosine of 29.524, and that divide that by 1. Or in other words, find the cosine. Let's see if I can do it. Let me see if I can do it here. And the cosine of 29.524, I'm looking for it in a calculator, equals, all right, give me 1 second. The cosine of that, so the cosine of 29.524, I'm going to write it down here, is, and I'm not going to round this number off, it's 0.870 0.87014 9354. So again, I just use the trigonometric identity, and I know that the secant is the same thing as saying 1 over the cosine. So what I did is, in my calculator, I found the value of the cosine of 29.524. Give me 1 second. 29.524. So the secant of 29.524 is, or the cosine of 29.524 is 0.870149354. Now I say 1 divided by this number, which again I use a calculator. And the secant, I'm actually going to go ahead and just give you the answer already rounded to 4 decimal places. But the secant of 29.524 degrees equals 1.1492. So it's actually not equals, it's approximately 1.1492. So this is actually the end of this section and the end of this video lesson, guys. Hopefully this video will help you and it will complement, and you guys can use it as reference for studying and completing your homework assignments. So until our next class, stay safe, guys. Bye.